Hello everyone, welcome to this video. In this video, we'll be solving another question based on special series. So the question here says we need to find the sum of n terms of the series where the nth term is given by n plus 3, right? This is the expression here. So here the nth term is given by n plus 3. So when you multiply the terms together, it would be equal to n square plus 3n. Now what is the, here we do not have to calculate an because it is already given to us in the question. So what we do here is we have to calculate Sn. For that we have to add for first term, second term, third term and so on up to n term, right? So this Sn is nothing but the value of a1, because n is given to be n square plus 3n. So when you substitute n is equal to 1 here, you have a1 which is 1 square plus 3n. When you substitute n is equal to 2, you have a2 which is 2 square plus 3 into 2, right? When you substitute n is equal to 3, you have a3 is equal to 3 square plus 3 into 3 and so on. So you have 1 square plus 3 into 1, 2 square plus 3 into 2, 3 square plus 3 into 3 and so on. The last term would be n square plus 3 into n. Now what you can do, you can collect all the first terms here in one brackets, because we have addition and addition is commutative. So you have 1 square plus 2 square plus 3 square and so on up to n square, right? And the last term is 3 into 1, 3 into 2, 3 into 3 and so on, 3 into n. So you see in each of these terms we have 3 common. So plus 3 into the terms which are remaining are 1 plus 2 plus 3 plus up to n, this term. Now what we can do, we can simplify the terms here. So 1 square plus 2 square plus 3 square up to n square, it is equal to n plus 1 to n plus 1 divided by 6. And then we have 3 here. The formula for calculating the sum of first n natural numbers, it is n plus 1 divided by 2, correct? So now what you can do, you can simplify the terms here and you have this as your answer, right? This is one way. Here what you have done, we are given some an, we have just substituted the values of n and then evaluated what is a1, what is a2, what is a3 and so on, right? And then we have simplified our result by collecting the like terms. We can also solve this question in summation notation. What is that? We can make use of this sign and use this notation in order to solve it directly instead of opening all the terms and then solving. So here you can write Sn, because you know what is your Sn. It is a1 plus a2 plus a3 and so on up to an. So you can write it like this. Sn is summation of ak, where k varies from 1 to n, right? So this term. So here the value of ak is what? It is k plus 3, right? So you can open up this term now, because summation is openable on addition. So you can write it like this. Why? Because you can you see, when you substitute 1 here, it would be 1 square plus 3 into 1, right? When you substitute 2 here, it would be this term. When you substitute 3 here, it would be this term and so on, plus so on. So you can collect the like terms together, right? Last term would be this. Then you can collect 3 into 1 plus 2 plus so on up to n. So you see, you can write it like this, summation k square, where k varies from, k starts from 1, ends at n. So you can write it like this. Here you can write this term like this, summation k, where k varies from 1 to n, because it starts from 1, it ends at n, and you can successively write it like this. This summation means addition, right? So therefore you can open up this summation sign over here and then substitute what is the value of this term. Actually the value of the sum of square of first n natural numbers, it is n plus 1 to n plus 1 divided by 6, and the sum of first n natural numbers, it is given by k plus 1 divided by 2. So you can simplify these terms. We have just performed and solved this thing above here. We obtain these terms. When we simplify them, we have this as our final answer. So this is our answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.